So we're going to learn about the sampling distribution and central limit theorem Shiny apps that we have. Now you'll notice there are in fact three here. We have one for the sample proportion, one for sample means of continuous populations, and one for sample means of discrete populations. They all have their own purpose, though you would want to first ask yourself to decide between the three. Am I dealing with categorical data, in which case you're using a sample proportion? Am I using quantitative data? And then if it's quantitative, you have to decide if your data is continuous or discrete. For purposes of this example, since they all work in a very similar way, I'm going to show you how the sampling distribution of sample proportion app works. In this app, we're using it to generate or simulate, if you will, what could happen if we take a sample. And that applies to all three of these different apps. Although they're different apps, they're all doing the same thing. They're simulating a sample based on the parameters that you're setting. So in this case, since we're dealing with sample proportion app, let's just say that we have a sample proportion of, I'm going to enter numerical data as, let's say, 0.62. And when I say sample size, it's how many of those samples do I want to take? So if I want a sample size of, let's say, 30, down here we say how many times do we want to do that? So in other words, how many samples of size 30 are we going to take? So let's start with 1 and see what happens. So in other words, this means that I have taken a sample of size 30, but only done it one time. You'll notice that it gives me here the mean, which in this case, right, the mean of that distribution is our population proportion. Now, if you look down at the third graph here, it's a little strange to look at just because we only took a sample of 1, but it tells us the mean of all of those samples. So let's say that I were to do this again, but instead of a sample only once, let's take 100 samples of size 30. So I'm simulating what would happen if I went and took 100 separate samples of size 30, and that is random samples of size 30. Down here where it says mean, that means that out of all 100 samples that we took, they took the mean of those population proportions. They found the standard deviation of those population proportions. You could also have it include your summary statistics at the bottom if you wanted. Just pointing out a couple of things here. There's also options. You could download the graph. You could include the distribution of successes, since we're dealing in this case when it's proportion as either success or failure. Now, something you'll probably notice, and this may look familiar depending on where in the course you are, is the more samples you take, you notice the closer this is going to become to the bell curve. May not be perfect, but the closer it can become to that. So what happens if we take 1,000 samples? We're starting to notice that there's a distinct peak in the center, and it's showing us here, if you look at the two dots that are on the graph, here's our population proportion, and then it says p hat, that's the sample proportion of that situation. So all of these are representing sample proportions. And in this case, our mean, remember, is the mean of all of these samples that we took. So again, if we did this one more time for 10,000, notice that again, it's getting closer to that visual of the normal approximation. I'm going to check this box just to show you how it kind of fits in here. So if we were to keep drawing samples, so let's say we just did this again and again to see what happens. Sometimes the mean might change a little bit. Sometimes it might be a little bit higher. Sometimes it might be a little bit lower. But it's always going to be very close to that population proportion of 0.62. So if it's not exact, it's going to round to roughly that number, especially if you're taking 10,000 samples. You're more likely to see that variation if you only took 1 or 100 samples. So in this situation, 0.623, much higher than our population proportion. Again, just trying to help you visualize what's happening. So the more samples that you take, the closer you get to the approximate normal distribution. So why are sampling distributions important? The sampling distribution of, in this case, sample proportions is just telling us, in theory, this is what could happen, right? So we're simulating values based on that sampling distribution. We're simulating those values to see what, in theory, could happen. And this is very heavily used when we get into confidence intervals and hypothesis testing. Basically, it allows us to determine roughly what should happen and then compare it to what actually happened. So that's where this ends up heading towards. Thanks for watching.